Hello everyone. So today we are going to discuss the chapter 2, which is polynomials for the EmSAT math practice. So let's begin. So this is our first question. Simplify the expression 3x squared minus 4x plus 5 minus 2x squared minus 3x minus 6. So we just have to simplify this expression. So let's write this expression out. So it's 3x squared minus 4x plus 5. Okay, minus, let's open the bracket. So minus, it's 2x squared. Okay, then this minus multiplied with minus 3x makes it plus 3x, and similarly this minus multiplied with this minus makes it a plus 6. Now we just have to simplify. We just see the like terms and do the calculations. So here it's 3x squared minus 2x squared, so we get x squared. Here it's minus 4x, and here it's plus 3x, so we get minus 4x plus 3x, we get minus x. And here it's a plus 5, and here it's a plus 6. 5 plus 6, we get plus 11. So this is our correct answer. Which option is it? It's our very first option. Now let's move ahead. Find the roots of the polynomial. So we have to find out the root of this polynomial. Now what kind of a polynomial is it? It's a quadratic polynomial. Okay, so we basically have to find out the roots of a quadratic equation. The equation being x squared plus 7x plus 12 equals to 0. What formula do we use to find out the roots? We can use the quadratic formula. Now, what's a quadratic formula? So, when a quadratic equation is given to you, which is of the form ax squared plus bx plus c equals to 0, then the roots of this quadratic equation is given by minus b plus minus square root of the discriminant over 2a. Now, what is the discriminant? The discriminant is equals to b squared minus 4ac. So now let's use the formula to calculate the roots. Let's first calculate our discriminant. What is b in here? Our equation is this. So if we compare these two, our b is nothing but plus 7. So it's 7 squared minus 4. Now what is the value of our a? Now a over here is simply 1. So we just put in 1 over here. 4 multiplied with 1. And what is our c? So c is actually 12. So let's write down 12. It gives us 49 minus 48, and so the value of the discriminant is 1. Our roots are minus b, so it's minus 7 plus minus square root of 1. Square root of 1 is simply 1, right? Over 2 multiplied with a. Now again the value of a is 1. So we get minus 7 minus 1 over 2 and minus 7 plus 1 over 2. This gives us minus 4, and this gives us minus 3. So our roots are minus 3 and minus 4. Which option is it? It is the very first option. No, there was a shortcut way to go. So let's discuss the short way. So if a quadratic equation is given to you, or a quadratic polynomial is given to you, which is of the form ax squared plus bx plus c, then the sum of its roots, the sum of the roots is given by minus b over a. Basically, the second coefficient divided by the first coefficient, and you have to put a minus sign before that. Okay, so that's the sum of the roots, and the product of the roots is given by c over a. Okay, so basically the last coefficient divided by the very first coefficient, and this time we don't put a negative sign. Okay, if we see our quadratic polynomial over here, what is the product of the root? Well, product of the root is c over a, which is 12 over 1. Yeah, so it gives us 12, isn't it? Yeah, and what is the sum of the roots? Sum of the roots is minus b over a, so we are left with 7 over 1 with a negative sign in front. So it's a negative sign, and then 7 over 1, which is just minus 7. We can check the options up which two roots are adding up to minus 7, and we see it's the very first root that is adding up to minus 7. This, if you add these two roots, you're getting minus 1. If you add these two roots, you will get 7. If you add these two roots, you will get 1. Okay, so on in this one you're getting minus 7, and you can also cross check using this, like the product of the roots. If you multiply these two, you should be getting 12, and yes, we are indeed getting 12. If you multiply minus 3 with minus 4, we will be getting 12. So since both of these conditions are satisfied with this option, hence this option is the correct answer. Let's move on to the third question. Find the degree of this polynomial. So we have to find out the degree of this polynomial, 4x cubed y squared minus 3xy cubed plus 2x squared minus 5y plus 6. Now, what is the degree of a polynomial? The degree of a polynomial is the highest power on the variable. So if we see the variables here are x and y's, and we want to find out the power on those variables. So here the power over x is 3 and the power over y is 2. So combined, the power over here is 5 on the variable in this term. Over here, the power on x is 1 and the power on y is 3. So if we combine those two, the total power is 4. Okay. Over here, it's only x and the power is 2. So it's just 2. Over here in this term, the power is 1, isn't it? Because it's just y. So the power is 1. Over here, there is no term. So here the power is 0. And now among these values, which one is the highest value? Indeed, 5 is the highest value. Hence, the degree of the polynomial is 5. Hence, option number C is the correct answer. Now, let's move ahead to the question number 4. The sum of the roots of the polynomial, this is what? So, it's asking us the sum of the root of 2x squared minus 5x plus 3. 2x squared minus 5x plus 3. Remember, we discussed the sum of the roots here. The sum of the roots of the quadratic equation is given by the second term over the first term with a negative sign. What is the value of our a? A is 2. What's the value of b? Well, the value of b is minus 5. Okay, and what's the value of c? The value of c is 3. And remember, the sum of the roots is given by minus b over a, which is minus of minus 5 over 2, which gives us 5 over 2. Hence, the sum of the root is 5 over 2. Hence, option A is the correct option. Now, let's move on to the question number 5. If x plus y is equals to 12 and x multiplied with y is 27, find the value of x cubed plus y cubed. Now, it's a tricky question. So, how do we solve this? Well, in order to obtain x cubed and y cubed, why not just try to find out what x plus y whole cubed is? Okay, and if you know its expansion, the expansion of x plus y whole cubed is x cubed plus y cubed plus 3xy multiplied with x plus y. This is the expansion of x plus y whole cubed. Now, remember, we have to find out this, isn't it? We have to find out x cubed plus y cubed. We already know the value of x plus y. What is the value of x plus y? It's 12. So let's fill in the value. So this gives us 12 cubed is equals to x cubed plus y cubed plus we also know the value of x multiplied with y. What's the value of x multiplied with y? It's 27. So let's fill it in. So it's 3 times 27 and this multiplied with x plus y. What is x plus y? X plus y is 12. So let's fill this in. Okay. So we are left with this equation. So what's 12 cubed? Well, 12 cubed is 12 multiplied with 12 multiplied with 12. And if you do it in your calculator, you will get 1728. So I can write 1728. And this is equals to x cubed plus y cubed plus. Now what's 3 multiplied with 27 multiplied with 12? Now if you do this, you will get 972. Remember, we have to find out x cubed plus y cubed. So why not just send this 972 on this side? Now if you send this on this side, obviously the sign of 972 will change. So here I'll have to subtract 972 and this is equals to x cubed plus y cubed, which means the value of x cubed plus y cubed is equals to 1728 minus 972. And if you calculate that, you will get 756, which is option number D. Let's move ahead to the question number 6. For which value of k does the polynomial p, which is equals to x squared minus kx plus k, have exactly one root? So we have to find out the value of k for which this polynomial is going to have exactly one root. So how do we find out the root? And this is a quadratic polynomial, so we already know the formula. So let's write down our quadratic formula. So if our quadratic equation is of the form ax squared plus bx plus c equals to 0, then the roots of that quadratic equation is given minus b plus minus square root of the discriminant divided by 2 multiplied with a. So we are getting two roots, isn't it? Plus and minus. But in this question, they are saying that we need only one root, exactly one root. How do we ensure that there are exactly one root? Because there has to be two roots according to the formula. Well, what if we make the value of d 0? If the value of d is 0, plus 0 and minus 0 won't make different roots. So our root will only be minus b over 2a. That will be exactly one root. Okay. So in order to make our d as equals to 0, we have to make b squared minus 4ac equals to 0. Remember, our discriminant was equals to b squared minus 4ac. Now, in this polynomial of ours, what's the value of b? The value of b is minus k. So it means we have to square the minus k. Okay, and minus 4, a is 1, and what's the value of c? C is also k. Okay, and this should be equals to 0. So over here we get k squared minus 4k is equals to 0, isn't it? Now we can take k as common thing and we get k minus 4 equals to 0. Now in order to satisfy this, either k should be equals to 0 or k should be equals to 4, isn't it? Hence both of these values are possible. Hence option A and option C both are correct for this particular question. Now let's move ahead to the question number 7. If x equals to 3 is a root of the polynomial p of x, which is this. Now this is a cubic polynomial over here. Then what is the sum of the other roots? Okay. The cubic polynomial can be generalized in this form: ax cubed plus bx squared plus cx plus d. Now, even in cubic polynomial, the sum of the roots is given by the second coefficient over the first coefficient. So, sum of roots is equals to, what is the second coefficient? The second coefficient is b and the first coefficient is a. And you put a negative sign before that. What's the sum? So, it's minus of minus 6 divided by 1. We get this as equals to 6. Okay, so the sum of the roots is equals to 6. Now in a cubic polynomial, since the degree of the polynomial is 3, we will have 3 roots, isn't it? And one root is already given to us. X is equals to 3 is a root, isn't it? We have to find out the sum of the other two roots. So we have got alpha plus beta plus gamma, the 3 roots. We add these up, we are getting 6. And one of the roots, let's say alpha, is given to us. We have to find out the sum of the other two roots, which is beta and gamma. Okay, so the sum of the other two roots can be given by solving this equation, and we get beta plus gamma is equals to 6 minus 3, which is 3. Hence option B is the correct option. Now let's move ahead to the question number 8. What is the remainder when the polynomial p of x is divided by x minus 2? So to solve this question, we need to divide p of x with x minus 2. So we can use division for that, or we can use the remainder theorem. Let's do it first using the division thing. So we have to divide this. Just focus on the powers. So over here it's x powered 1, over here it's x powered 4. So we have to multiply this with cube, isn't it? We have to multiply it with x cubed. And since the coefficient over here is 3, we have to multiply it with 3x cubed. Okay, now when we multiply x minus 2 with 3x cubed, what can we get? We will get obviously 3x cubed multiplied with x. We will get 3x powered 4, and we will get 3x cubed multiplied with minus 2. We will get minus 6x cubed, isn't it? And if we subtract these, we cancel out the 3x powered 4. So this becomes 0. And now we are getting minus 2x cubed minus 6x cubed. So it's minus 2x cubed minus 6x cubed. It gives us minus 2x cubed plus 6x cubed, which is 4x cubed. So we can write 4x cubed over here, and I can bring this term down. So it's 5x squared now. Now again, just focus on the power. Here it's power 1, here it's power 3. So we have to multiply it with x powered 2, isn't it? Because 1 plus 2 gives you 3, and here the coefficient is 1 and here the coefficient is 4. So we have to multiply it with 4. If we multiply 4x squared with this, we will get 4x squared multiplied with x. We have 4x cubed, and when we multiply 4x squared with minus 2, we will have minus 8x squared. And if we do the maths, obviously when you subtract, these two cancel out, and when you subtract minus 8 from 5, so it becomes 5x squared minus 8x squared, so it will become 13x squared. Okay, and now the minus 7 will come down. Again focus on the term with the highest power. So here it's x squared and here is x powered 1. So obviously you have to multiply it with x powered 1 because 1 plus 1 gives you square, and here the coefficient is 13. Multiply it with 13. Okay. Now obviously when you multiply it with 13x, I'll be having 13x squared over here, and when I multiply 13x with the other term, I'll get 13x multiplied with minus 2, I'll get minus 26x. Now again, obviously these two terms will cancel out when you subtract, and you will be having minus 7x minus minus 26x. So it's minus 7 plus 26, which will leave us with 19x, isn't it? And obviously I can bring this 4 now, plus 4. Now here it's x powered 1 and here it's also x powered 1. So we don't have to worry about the power. So we just have to worry about the coefficient. The coefficient here over here is 19. So let's just multiply it with 19. So we will get 19x over here, and we will get minus 2 multiplied with 19. We will be getting 38. Okay. So obviously the 19x cancels out and I'll get 4 minus minus 38. So it gives you 4 plus 38, which is 42, which is the option number second. Okay. Now this division was kind of lengthy, isn't it? It's lengthy. So there's a shorter way to do that. There is a shorter way, and that shorter way is actually called the remainder theorem. Remember what we were dividing? We were dividing our polynomial p of x with x minus 2, isn't it? And we were trying to find the remainder. So the shorter way to do that is we check for the root of the divisor. Over here, the dividing polynomial is x minus 2, isn't it? This is the polynomial which is dividing our p of x. X minus 2 is dividing our p of x. What is the root of x minus 2? Obviously, the root of x minus 2 is 2, isn't it? When you find out its root, what you have to do is you have to put this inside of p. So you just have to find out p of 2, and this p of 2 is going to be your remainder. Okay, so let's find out p of 2 and let's see if it's equals to 42. So p of 2 would be 3 multiplied with 2 power 4 minus 2 multiplied with 2 power 3 plus 5 multiplied with 2 power 2 minus 7 multiplied with 2 plus 4. Okay, so we just put in the value of the 2 inside of our polynomial, and if you do the maths, you will indeed see that this is equals to 42. And that's how our remainder theorem works. Once again, you just have to find out the root of your divisor, and you have to put that root inside of the polynomial p of x which is being divided, and you will get the remainder. Now let's move ahead. A similar kind of question: which of the following is a factor of this polynomial? So our polynomial is given to us, which is x cubed plus 3x squared minus 4x minus 12, and I have to find out its factor. Now if something is a factor, it means it leaves us with remainder equals to 0, isn't it? The remainder should be 0 if I'm dividing it with its factor. For example, 3 is a factor of 6 because 3 divides 6, and when you divide it, the remainder is going to be 0. So over here we can again apply our remainder theorem to solve it quickly. Or the lengthier way to do that is you can keep trying every option. You can divide this polynomial with x minus 2 and see if the remainder is 0. You can try it with this and see if the remainder is 0. You can try it with this and see if the remainder is 0, and you can try it with this and see if the remainder is 0. Now division will take a lot of time. So what we are going to do, we are going to be applying the remainder theorem over here and check if the remainder is 0. So what is our first step? The first step is finding out the root of the divisor. So the root of the divisor is going to be a plus 2, isn't it? So we just have to find p of 2 and check if this is giving us 0. So let's find out p of 2. So we will get 2 cubed plus 3 times 2 squared minus 4 times 2 minus 12, isn't it? And if you calculate this up, we are getting 0. So it means x minus 2 is dividing this polynomial and leaving us no remainder. Hence, it's a factor of this polynomial. Hence, option A is the correct option. Now, let's check up with the option number second. And you check with the option number second. What is the root of this polynomial? What is the root of the divisor? The root of the divisor will be minus 2. So let's put in minus 2 over here and let's see what we are going to get. So we're going to get minus 2 cubed plus 3 times minus 2 squared minus 4 times minus 2 and then minus 12. So this gives us minus 8 plus 12 plus 8 and a minus 12. And this leaves us with 0. Hence, option B is also a correct option. Now let's check for the third option. Here, the root of this polynomial is going to be a 3. Now let's plug in 3 in the polynomial that we are dividing. So let's find out P of 3. So it's going to be 3 cubed plus 3 times 3 squared minus 4 times 3 minus 12, isn't it? So it's 27 plus 27 minus 12 minus 12. Now this is definitely not equals to 0, isn't it? Yeah, because this is going to be equal to 54 minus 24, which is 30, and this is not 0. Hence this option is not correct. Now let's go to the fourth option. For the fourth option, what is the root? The root is going to be a minus 3. So let's plug in the value of minus 3 in the polynomial. It's going to be minus 3 cubed plus 3 times 3 squared minus 4 times minus 3 and a minus 12. Okay, so it's going to be minus 27 plus 27 plus 12 minus 12. Again, this will be equals to 0. Hence, option D is also the correct option. So, for this particular question, it's option A, B, and D. All three are correct. Now, let's move on to the 10th question, which is our final question. To find out the value of A, if x minus A is a factor of this polynomial, again, if x minus A is a factor of this great polynomial, so if it's a factor, obviously we will be applying remainder theorem and we will be seeing if the remainder is 0 or not. Okay, so again we will be doing remainder theorem. Okay, now who is the divisor over here? X minus A, isn't it? Now what is the root of this particular polynomial? Well, the root is A, isn't it? Now we have to plug in this value of A in this polynomial. Our polynomial is P of x is equals to x cubed minus ax squared plus 2x plus a minus 1. So let's put in a over here. So we will replace every x with a. So we will be getting a cubed minus a multiplied with a squared plus 2 multiplied with a plus a minus 1. So we will be getting a cubed minus a cubed plus 2a plus a, which gives us 3a minus 1, isn't it? This is going to be our P of A, and this is going to be our remainder. And since it has to be a factor, the remainder has to be equals to 0, isn't it? And a cubed and a cubed cancels out, so we get 3a minus 1 is equals to 0. So we can say that 3a is equals to 1, which means a is equals to 1 over 3. Hence, option B is the correct one over here. And that's it.